Cyclohexane is the next ring up from the C5 to the C6, and this is the more interesting one because we're going to be able to illustrate a lot more interesting concepts such as equatorial and axial bonds. But let's start simple. So if we have 6 carbons in a ring, we have cyclohexane. We cannot actually create a planar conformation. No matter how you try to twist this ring, the carbons are going to constantly try to pop out. So we don't have the planar conformations like we did with cyclopropane and cyclopentane. We do have a few more interesting conformations though. So the easiest one to see is the boat. So the boat, we're going to have 2 of the carbons puckered out of the ring and then 4 carbons in plane. So the way we would draw this is to replace our solid lines with wedges. And if we were to look at it side on, what we would see is what sort of looks like a boat. Now, the boat here is going to be a more stable conformation than if you try to force it planar, but there is a small issue with this. If we put our hydrogen atoms in with these sticks and look at it, and we actually make a perfect boat conformation, we have 2 hydrogens that are pointing at each other. So another option here is the skew boat. The skew boat is basically going to take the boat, but it's going to slightly twist it off axis. So that if we look down these 2 carbons, we see that the hydrogens aren't directly end on end. They're not eclipsing each other, which is what we would see if we actually had the true boat conformation. Now, the skew boat's going to be slightly more stable, but the trade-off with taking these hydrogens out of plane with each other, giving them a non-zero dihedral angle, is that you're going to strain the other bonds. Now, the far more stable version of cyclohexane here is going to be, get it worked out, is the chair conformation. And this is going to basically, if we look at the side, it's going to look like we staggered all the carbons in a ring. So the way we would represent this is we have our dashes going down for our CH2 group, and set of wedges going up for our other CH2 group. So this chair conformation, called so because it kind of looks like a chair if you put it at an angle, this is going to be one of the most stable conformations. Now, in the next video, we're going to start talking about looking at the Newman projections to understand axial and equatorial bonds. But this is the most stable conformation because what it does is it puts vertical or axial hydrogens and equatorial atoms or equatorial hydrogens furthest away from each other. So these are your 2 conformations: skew boat, boat, well, technically 3, boat, skew boat, and your chair conformations.